Hello everyone, welcome back to our maths class. So in our previous class we discussed how to find the HCF of a given number, right? So how we found the HCF there? First we will find the factors of the given numbers, then we will list down which are the common factors, and from the common factors we find out which is the greatest one, right? There were three steps, right? So today in this class we are going to find the HCF of given numbers by prime factorization method. Okay, so we have already studied how to find the prime factorization. Okay, we studied how to find the prime factorization of the given numbers, and we have gone for two methods, the factor tree method and also the short division method, right? So here we are going to use the prime factorization, and then we are going to find out the HCF of the given numbers. Okay, so here we are given two numbers 81 and 117, and we have to find the HCF of these numbers. Okay, so and it must be done through prime factorization. Okay, so first we have to do the prime factorization of these numbers. Okay, so I am going to do the prime factorization and taking one by one number at a time. So, I am going for the short division method. We have studied how to find the short division method, and in that how we are doing, we will use only the prime numbers to divide these numbers, right? So here our number is 81, and 81 is not divisible by 2. 2 is not a factor of 81. So which is the next prime number? 3. So 3, we are going for 3, and 81 divided by 3. What is 81 divided by 3? When 81 is divided by 3, we will get the quotient as 27. 27. Okay, 81 divided by 3, we will get the quotient as 27. So we are writing the quotient here. We have studied how to do the prime factorization in our previous classes, right? So now 27. 27, again 27 is an odd number, so it is not divisible by 2. So going for our next prime number 3. So 27 divided by 3, what is it? 27 divided by 3, we will get 9, right? Again dividing 9 with 3, we will get it as 3. Again 3, dividing 3 with 3, we will get the quotient as 1. Okay, so now we got the quotient 1, so now we can stop our division, right? So we will stop our division here, and we can represent this 81 as the product of these prime numbers, right? So 81 is equal to 3 into 3 into 3 into 3. 3 into 3 into 3 into 3. Okay, so we got the prime factorization of 81. Now moving on to our next number 117. So now we can do the prime factorization of 117. So again we are going for our prime numbers with 2. It's not possible here. We cannot divide 117 with 2. So we will move for our next prime number. It is 3. So on dividing 117 with 3, we'll get it as 39. 117 divided by 3, we'll get it as 39. Okay, so we are writing that quotient here. Again 39, dividing 39 with 3. 39 divided by 3, we will get the quotient as 13. 1, 3, 13. Okay, again 13. Look for 13. 13 is a prime number, right? So the only factors of 13 are 1 and 13 itself. So we can divide 13 with 13 itself, and on division we will get the answer, the quotient as 1. Okay, so here also we got the quotient 1. So here we can stop our division. So which is the product 3 into 13, right? So our first step is over. We find out the prime factorization of given numbers, and we wrote our numbers as the product of the prime numbers. Next step is to find out the HCF of these numbers. HCF of 81 and 117. Okay, so first what we have to check? We will check which all the prime numbers are common in 81 and 117. Okay, so first there is a 3 in 81, and for this 3 we could find another 3 in 117, right? So it is a common one. So here this 3 is common, and also this one. Okay, in 81 there is a 3, and corresponding to that in 117 we could find the 3. So we can write that 3 here. Okay, so it is 3 here. And again there is another one more 3 in 81, and we could find another 3 in 117 corresponding to that. So again this 3 is common in 81 and 117. So we can circle it and write it down here in the HCF. So HCF of 81 and 170 is 1 3 is there into, again a 3 is here, right, into 3. Okay. Next there is one more 3 in 81. Okay. But we cannot find any more 3's in 117. So it is not common, right? So it is not common. So we cannot write it in the HCF since it is not common. Same in the case of 13. 13 is the factor of 117 but not a factor of 81. So we cannot write it in the HCF because we need only the common factors, right? So the common factors and the HCF, here the HCF of 81 and 117 is 3 into 3, which is equal to 9. So find out the HCF of 81 and 170, and it is 9. Okay. Moving to our next question, and here we are given 3 numbers, 48, 54 and 90 is there, and we have to find the HCF of these numbers through prime factorization. Okay, so we will go for each number by, one by one, and we will do the prime factorization of these numbers. Okay, so first we are moving on to our number 48. Okay, so 48, it is, first we are asked to take only the prime numbers to do the division, right? So first we will go for 2. 48 divided by 2, it will be 24, right? 24 is there. Again 24 divided by 2, what will come? 12 is there. Again 12 divided by 2, we'll get 6. 6 divided by 2, we'll get 3. Again 3 divided by 3. 3 divided by 3, we will get the quotient as 1. So we can stop our factorization here. So 48, the prime factorization of 48 is over. Again, moving on to our next number, it is 54, right? So we'll do the prime factorization of 54. 54 divided by 2. What is 54 divided by 2? We'll get it as 27. Then 27 divided by 3. 27 divided by 3, it is 9. 9 divided by 3, we get it as 3. Again 3 divided by 3, it is 1. So we have done the prime factorization of 54. One more number is there, 90. 90. And doing the prime factorization of 90. 90 divided by 2. What is? It is 45. Again 45 dividing by 45. We are dividing it by 3. 45 divided by 3. It is 15. Again 15 divided by 3. We'll get 5. 5 divided by 5. 5 is a prime number, right? So we can divide it by 5 itself. So it is 1 here. Okay. So we have done the prime factorization of these 3 numbers. Okay. So now we can write it here. So 48 is equal to 2 into 2 into 2 into 2 into 3. 48 is equal to, here written 48 as the product of prime numbers. Next, 54 is equal to 2 into 3 into 3 into 3. Okay. Next, 90 is equal to 2 into 3 into 3 into 5. Okay. So we have written these numbers is the product of prime numbers, right, after doing the prime factorization. So our next step is we have to find the HCF. Okay, so HCF of 48, 54 and 90. 48, 54 and 90. And how we are finding the HCF? We will look at the prime factors and we will see which all are the common factors for these three numbers. Okay, so it is, look here, for 48 we can find a 2 here, and also there is a 2 in 54, and also in 90 we can also see a 2 here. So 2 is common for the three numbers. Okay, so 2 is here. Okay, next, looking for the next 2, we can find this 2 in 48, but no more 2's are there in 54 and 90. So we cannot take 2, 2 is not common. Okay, so no other 2's can be taken. So next, moving on to 3. 3 is there in 48, and we could find a 3 in 54, and there is also a 3 in 90. So 3 is common, right? So again this 3 is common in 3 numbers. So we can write 3 here. So it is into 3 also. Okay. So HCF for 48, 54 and 90 is equal to 2 into 3, which is equal to 6. Okay. So we studied how to find the HCF of the given numbers using prime factorization method. First we will do the prime factorization of the three numbers. Then what we will do? Then we will write the numbers in the product of prime numbers. We will write the numbers as the product of prime numbers, and from that we will find the HCF. Okay, so hope it is clear to you. Thank you, and we will meet in our next class. Okay.